the trapezoidal rule, correct? And we said that the trapezoidal rule is second order accurate, and the area which we skipped is the area at which we introduce error in the scheme or in the calculation. طيب. Can we do something better than that? Can we do something better than that? What do you suggest in order to reduce the error? Other than increasing the number of segments or intervals. What else can we do in order to enhance that?
نقلل مساحة الانترفال الواحد.
Yeah. Other than that, what can we do in order to have a better approximation?
الكيرف من فوق دكتور.
نعم.
الكيرف من فوق اللي هو نسبة الإيرور اللي تصير.
Okay, curve. Okay. So guys, rather than having a straight line over there, what do you think if we had a curved line? A parabola, for example. Rather than having a straight line, something like that, we can have maybe a parabola in order to decrease the area between the actual function that we want to integrate and the segments that we have. So this is the idea and the Simpson's rule. So Simpson's rule said, let us introduce quadratic function. So let's say maximum 5 minutes. Let's see how can I will drive it, and later on we'll see how can we use it. So, okay. So this is a parabolic function. Okay, and the interval over here minus d to d. And let me say that function is given as a plus bx plus x squared, okay? Plus cx squared. Let me erase that and write it as cx squared, okay? That is the curve. So now if I take this y, which is a function of x, a plus bx plus cx squared, and I integrate it from minus d to d, y function of x dx, I will have, let me write it explicitly, minus d to d, a plus bx plus cx squared dx, right? So this gives ax plus b over 2x squared plus c over 3x cubed, correct? And you need to evaluate it from minus d to d. Okay, so let's evaluate that. So that is a d minus d for that term, plus b over 2 times d squared minus d squared, correct? Plus c over 3 d cubed minus d cubed. Let me erase it one more time. Minus d cubed. So, did you all follow me on that? Yeah?
Yes.
Yes.
So if I continue on, you will see that it gives 2ad plus 2 over 3 cd cubed. Okay, this is a simple algebra that you can go through it, right? This is a simple algebra that you can go through it. Okay, you can see that this cancels out over there. And the 2 comes over here and 2 comes over there. So that's why 2AD plus 2 over 3 CD cubed. طيب. Now, let us take that
دكتور.
function that we have over.
عندي سؤال دكتور.
تفضل.
الحين دكتور التربيع مو المفروض يصير برا القوس لا على الدي يوم
This
عوضنا.
one? This one?
ما
That
أشوف.
one?
إيه هذا المفروض يكون تربيع برا القوس لا مو عليهم.
Okay.
والله أنا غلطان دكتور.
برا القوس صاير لا. هذا القوس just to say that I'm evaluating that b over 2 x squared. One time you evaluate it as d squared minus d squared.
أوكي دكتور. أوكي أنا
Okay.
مخرب. إيه.
No problem. طيب. Okay, so let me right now evaluate the function, this function over there, 1 time minus d. So I will have, just substitute minus d at x. So this becomes a plus, a minus bd plus cd squared, all right? And then evaluate it at 0, okay? At the midpoint over there. So this gives you just a, right? Every time you have x, substitute 0. And evaluate it at d, at the other edge of the interval. So this gives a plus bd plus cd squared, right? That is equation 1, this is equation 2, and that is equation 3. Now, the question is, what can we do in order to add them in such a way, those equations, okay? I want to evaluate the function at this location, and evaluate this function at 0 location, and evaluate the function at that location, okay? Such that at the end of the day, I will get that result. This is the result of the integration, correct? So it turns out, if we add equation 1 plus 4 times equation 2, coefficient 4 times equation 2, plus equation 3, we will recover that solution again. Okay, we will recover that solution again. Okay, so now let me write it as follows. So integrating y of x dx from minus d to d equals d over 3 times y1 plus 4y2 plus y3, okay? So this is the value of the function, that is y1, that is y2, and that is y3. So if we add y1 plus 4y2 plus y3 and multiply the whole thing by d over 3, we will get the exact value of the integration. So basically, that is Simpson's rule. That is Simpson's rule. And one important factor over here, n, which is the number of intervals, okay? Number of intervals. In this case, n must be even. And in this case, The number of intervals that we use must be even, unlike the trapezoidal rule, which odd or even intervals work the same. Okay, so شباب, approximating a function from A to B equals, let me just write, it's not very clear, but at least 1/3 times D. Evaluate the function at y1, y2, y3. This is the first interval. Then 1/3D. Evaluate the function at the second part of the intervals and add them all up. Let us see the following example in order to kind of find the final form of the Simpson's rule. So let us integrate the following function. Okay, dx, and this function goes. I think I will add more space over here. I will add more space over there. And this function can I do something like that? Yeah. Undo. One more time. One more time. Okay, so this function goes. This function is from, let's say, 1, then 2, then 3, then 4, then 5, 6, and 7. Okay, let us integrate this function, the following function. Just a minute, guys, just a minute. شباب ثانية واحدة ها. طيب شباب معكم مرة ثانية. Okay, so from 1 to 7, okay, I want to integrate this function from 1 to 7. So based on that formula, the integration approximately equals h/3. Okay, h/3 multiplied by, take it as a common factor, the function evaluated at 1, f1. By the way, guys, I am at the first interval, plus 4 times f2. Okay, plus 4 times f2, plus f3. Okay, since we are taking even number of intervals each time, right? Okay, so that is the first 2 intervals. Then let us move to the next one. The next 2 intervals. I think I can zoom in a little bit. طيب. So plus the function evaluated at, look at that location. هذه بداية الانترفال f3 plus 4 times the function evaluated at the mid of the intervals, 4 plus the function evaluated at the end of the intervals, 5. Okay, so done with the second pair of intervals. Let us move to the next ones. So let's move to the ones over here. So I will have plus the function evaluated at
5.
5 plus 4 times the function evaluated at 6 plus the function evaluated at the end of the interval 7. Now let's close everything. طيب شباب. Now tell me, what do you notice? Can you see that 3 is summed twice?
Yes, دكتور. وحتى
And
الخمسة.
what else? 5 is summed twice. Can you see that? Can you see that 2, 4, and 6 are summed 4 times? 1, correct? Are summed 4 times. Finally, can you notice that the edges of the the limits of the integration, بداية الانترفال ونهاية الانترفال, are summed only 1 time? Is that clear? So you know what? We can generalize it now. We can say that integrating a function, any function, using Simpson's rule, dx equals h over 3, the width of the interval, multiplied by the function evaluated at the first limit, okay, plus. So what is the common thing over here?
كلهم even.
كلهم even. So 4 times the summation of the function evaluated at the even points, okay, plus شنو صار عندنا العامل المشترك بين 3 وال 5 and 7 and 8 and 9 and what is the common thing?
كل مرة يزينون 2.
Which means they are odd points, right? And 2 times the summation of the function evaluated at the odd points plus the last limit. Okay? Plus the last limit. Guys, this is called Simpson's rule.
دكتور ليش ضربناها في الاثنين؟
لأن 3 انجمعت مرتين. 5 و5 انجمعت مرتين. Clear?
Clear.
تمام. Okay, شباب. So that is Simpson's rule. And by the way, it's called Simpson's rule, 1/3 rule. Right. What is important here? What are the important points? First of all, this works on even number of points. Sorry, even number of intervals. What else? The error, guys, over there, using the Simpson's rule, is of the order h cube, and that this error is not in each interval. This is the global error. In comparison to the Simpson's rule, in comparison to the trapezoidal rule, which was square, correct? So which one is more accurate?
This one.
Simpson's rule is more accurate. Right. Okay, so let us, guys, now solve the same problem using Simpson's rule. We solved that problem last time. So what do we need to do? Let's take n as n equal to 4. Will that work? Yes, because this is even number of intervals. Right. So what shall we do? We need to define x and we need to define f of x, right? So we started at 1, and the last limit is a 3. So how much is h? You remember b minus a divided by n. So that is 3 minus 1 divided by 4. So that is 1/2, correct? So if you start at 1, then the next one is 1.5, then 2. Okay, then the next one is 2.5 and the 3. How many intervals do we have? That is the first interval, the second, the third, and the fourth one. Right? At each point, you will evaluate f1, f1.5, f2, f2.5, and f3. Okay, guys. So based on this formula, how can we apply it? How can we apply this formula in order to find the numerical integration using Simpson's rule? I think one of them is clear, right? Those points, the limits, are summed only one time, right?
عادل دكتور.
Okay. So what about this point over here? Notice.
والله ما أدري.
1, شباب, that is the first point, the second point, the third point, the fourth point, and the fifth point. صح؟ 5 نقاط. Always we said number of points equal n plus 1. Intervals plus 1. Okay, that is the first point, that is the last point, are out of the scope because they are only summed one time. At 1.5, this point, is it even or odd? Even point, right? That point, 2.5, it is even point, correct? And point number 3, 2, is an odd point, isn't it? شباب احنا ما قاعد نطلع الرقم. We are not looking at the value of the number. We are looking at its order, its location. Is that clear? So the 1.5 is an even point. 2.5 is even point. So they will be summed 4 times, correct? And what about point number 3? It will be summed twice. So now the Simpson's rule says, for this problem, it equals the integration using Simpson's rule approximately equals h over 3, and I think we calculated h over 3, multiplied by the function evaluated at 1 plus 4 times the function. The function evaluated at 1.5 plus the function evaluated at 2.5 plus 2 times the function evaluated at 2 plus the function evaluated at the last limit, 3. Okay, so basically, Shabab, that is the function evaluated at the first limit, the function evaluated at the last limit, and here are the function 4 times the function evaluated at the even points, And here is the function, 2 times the function evaluated at the odd points. Is that clear?
كلير يا دكتور.
Okay. So let's skip that because I assume you know how to do it manually. You will just find those values and will apply this formula. So now let's see how can we implement that in MATLAB. So what shall we do in order to implement that in MATLAB?
أول شيء نعرف ال N ونحسب ال H.
Okay, so let's open live script.
نعرف ال A وال B.
So let us define the number of intervals. Let's say 4. And the limits. A equal to 1 and B equal to 3. Okay, then calculate the interval length, right? H equal to B minus A divided by N. Okay, then what about the function? Or what about X? X equals A
له 1
with the increment of H all
واحد
the way to
ليس
T.
ثلاث.
Okay. A with increment of H all the way to B, and we make it as a column vector. Okay, we make it as a column vector. Okay, what about F? The F, this time it's a vector, right? What was the function again that we want to integrate?
H over 3.
Any 2 over
square X.
2 over square, 2 over square root of X.
ما بنحط دكتور الانتجريشن.
Still, the integration is the next step, right? Here I'm just showing X and F. Here I'm showing just the value of X. X1, X2, X3, X4, X5, and the corresponding the value of the function at each point. Okay. Now, how can we find that value of integration? Simpson's rule. Okay. How can we find the value of that integration? What should it be? H over 3. Okay, H over 3 times. طيب.
F of A.
F1.
شباب, this F, is it a function or it's a vector?
Vector.
Vector.
Vector. So F 1.02 does not work. Do you agree?
Yes, doctor.
Okay, so in that case, I need to take the index of the first interval. That is F1. Okay, come on. And what else?
4 F2 plus F3.
4 times. Shabab, how can I find the even points? 4 times summation. Summation of what? The even points. How can I find the even points? I want to sum that point, 2 and 4. ولو كان عندي أكثر I want to sum the even points only. So 2 is an even point, right? Then 4, even point, 6, 8. So I can say that with increment of 2 all the way to n. So that gives you point number 2, point number 4, And since n equal to 4, it will stop over there. So that is the even point. Those are the even points. And if you want to see that, let's just see that code before we continue. Let's see that. So basically, that is 1.6 and 1.2, 1.6 and 1.26, okay? Those are the even points. Similarly, if we do that on X, you will see that the even points are 1.5 and 2.5. Clear? So we include only the even points over there. So that is those are the even points. Plus, how can we do that for these odd points? 2 times summation of the odd points. How can we call only the odd points?
3 increment 2 to n.
So n, exactly. Okay. So we added only the odd point and then plus f evaluated at the end, or n plus 1. Okay, so let us run this code now. 2.9291. Okay. Do you recall how did we do that for Simpson's rule? For the trapezoidal rule?
It was h over 2 and then f1
over 2 times, okay.
we opened the bracket f1
1 plus
f open bracket n plus 1.
اوكي طب خليها في الاخير. In between what we have. In between what we have. خلاص.
دكتور كان بس مجموعهم كأنه
Times the summation of the midpoints, right? F at 2 all the way to n, correct? Plus the function evaluated at the end. I assume that was that is the value of the function that we got last time, 2.9447, isn't it?
صح.
Okay. So if we want to compare it to the exact solution, what did we do? We said sums, introduce a new variable, and in that new variable, I want to I exact equals, I want to integrate 2 divided by square root of xx from the limits a and b, and of course that value won't give you a rational number. Okay, so we said convert it to double in order to have it as a rational number. 2.9282, which you can clearly see that the Simpson's rule is more accurate in comparison to the trapezoidal rule, having the same number of intervals. So how can we calculate the error? So error Simpson absolute value of I exact minus I Simpson divided by times 100. The same thing as error for the trap, like that, yes.
دكتور كنا نقسمها على الإكزاكت.
Oh, yes, you're right. We divided that by the exact value, yes. Absolute value I exact minus I trapezoid divided by I exact times 100, and we can, sorry, pair both of them. Error trapezoid and error Simpson. Let's run that code again. Notice, guys, this is 0.5%, where the Simpson's rule is 0.03%, which clearly you can see that this is way more accurate in comparison to the trapezoidal rule. طيب شباب, didn't we say that increasing the number of intervals will enhance the solution and will decrease the error?
صح دكتور.
Okay, so what do you think if I increase it to 5?
بيقل الإيرور ويصير أقرب للإكزاكت.
Okay, so now let's do that over here. No, remember those values. We will use them. We will refer to them right now, 0.56 and 0.03. And we say that trapezoidal rule is much better. Okay, let's run this code again. What happened to the error using the trapezoidal rule? It went from 0.56 قل إلى 0.36, which means, okay, increasing the number helps out, right? But what happened to the Simpson's rule using 5 intervals? The error is way more larger right now. It's 5%. Even though we increase the number of intervals. ليش شباب? As we said earlier, this works only for even number of points. Okay, so now using 6 intervals, look at the error. Oops, it's way smaller than the trapezoidal rule. Okay, and for 11, for example, not necessarily, yeah, it is not good for odd number of intervals. Okay, and so on. 1,000, you can see that the error is less than 10 to the minus 5. Is that clear, guys?
Clear, doctor.
طيب. Now, if f is not a vector, if f is a function, what shall we do? If f, let me say f2, as we did last time, it's a function of x, and this function is given as 2 divided by square root of x. Okay, so guys, what do we need to change in this code?
دكتور صوب بس كل increment له إلا خلينا حط بس x.
How can I fix that now?
ألو صوتين سامع دكتور؟
إيه أسمعك.
بس دكتور بتحط x صوب ال f.
Okay, so let us, for example, take this code, this line, let me call it Simpson's 2. Okay, and that is f rather than 1. 2 is a function, right? I will evaluate it at a, at the beginning of at the first limit, and rather than it's a function, so that could be replaced by f b, right? This the second limit. What do we have to do in between? So this is a function of x, but these I need only the even points of x. Okay, x, the even point only. Similarly here, I need only the odd points. So x, the third, and the fifth, and the seventh, and so on. شباب هاي بس الزيادة الفرق الوحيد اللي لازم نسويه. Let's run that code. Logical or oops, that should be F2. And that should be F2 as well. Because F2 is a function. Let's see. That is something to, and that is something using a vector. Is it clear, guys? The difference between having a vector and having a function.
أسألك دكتور.
نعم.
الاختبار احنا نختار ولا كيف؟
لا. Okay. If it was an open question, it's up to you. But if, for example, okay. For example, if the problem was as follows, let's see. Let me write on the screen. If the problem was find the integration. Okay. Oops, I can't write. So anyhow, let's write it over there. Okay. Let's say in the exam or in whatever problem you were given, what happened? Okay, you were given the following: x and y, a table. Okay, and the question said, find the value of the integration. Then by definition, you cannot use that, right? You cannot use the function approach. You cannot use function because the function is unknown for you. You only have to introduce the values as vectors, right? Is it clear? But sometimes the original function is given and you need to integrate it numerically using whether trapezoidal or something. So then you have, it's your choice. It's up to you whether you want to introduce f as a vector or introduce f as a function. But in this case, you don't have an option. Is that clear, guys?
واضح يا دكتور.
Right, sure. So we will add a few problems or on this topic. Let me kind of now stop recording.